Good morning, Glenn.
Good evening, David.
So we are again recording an FPGA Talk here in this podcast. Welcome back and Happy New Year.
Yeah, thank you. Happy New Year. Almost Happy Easter.
Happy Easter.
Good to be back. Yeah.
It took a long time, yeah.
That's right. That's how it goes.
Welcome to the world of FPGA Podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. So today we have planned to talk a little bit about design approaches where we have started in our beginning as we have started as FPGA engineer and maybe what we are doing today and can try a little outlook into the future, where we will go in the future. So I don't know, maybe you want to start with where have you started with or what is your design approach at the beginning and what are you doing now when you're starting with the design?
Yeah, sure. So I guess when I sort of came into this, it was still after the schematic entry sort of approach was finished. So in university, we really just started with VHDL itself, so just RTL entry, I guess you could say. And this was still pre-Vivado days, so we were still using Xilinx ISE, and we were using the Quartus software available at the time as well, because basically we were working on a Spartan 3AN, I think it was called, and a Cyclone 2. So both of those were before, your SoC-based FPGAs, simple devices. And so it was all still really VHDL, direct RTL entry. So just your usual, processors for clocks and all this sort of stuff and constraints. So really just VHDL in source files, so a top level, and then other files for your various components that you then bring together, and then just constraints you'd apply to your top level in both Xilinx and Altera devices. So it wasn't really until Vivado came out where those other flows were sort of more becoming available and looked into. And so when Vivado landed and we were using the Zincs, so this would have been around 2014 for me, at the end of my university degree, we were at least using the IP wizards to define cores. So things like your clock wizard, and we were doing some projects with DDS. So we were specifying, how many bits you use for your phase counter, this sort of thing. So we could see, in a nice sort of way how our parameters affect the resource count and how the interfaces look at a glance with blocks, which is really cool, really nice. So that was quite a big step from ISE, I found, in terms of just getting a feel for IP cores work at a glance. So that's kind of, and then I think in Quartus we were using their equivalent as well. It could have been, I'm trying to remember now. We were using some tool where we could at least define things like state machines and stuff like this, but it was very, very, it was very basic, and it took a lot of effort to get anything done. So actually that was probably very much like schematic entry, to be honest, but at a slightly higher level. Not much. It was just sort of a state machine where, you'd have your circles for your various states, and you'd have your links, and then you just sort of draw connections as your nets through your design. So that's my sort of early days to, I guess, inputting designs, is really just your VHDL, and then kind of starting to transition to newer ways of working with just specifying the IP cores in Vivado, but not doing any sort of more larger scale block design at that point. It was still very much you generate your IP core with the GUI, and then you would just copy and paste the components and port maps. So that's sort of my early experience of working with the FPGAs. I never really got to go into the schematic entry where you were sort of dropping gates and that, I guess. I'm not sure. I've never even done it, so I don't know how it looks. But how about yourself, David? How does your intro look? the design entry?
It's funny. It's exactly this schematic entry where I've started. So
good. Educators.
Yeah. At university, I've never had anything to do with FPGAs or VHDL or things like that. So I've was more in electrical systems for medicine systems or for medical components, but nothing to do with programmable logic. A little bit of DSPs and programming in C and things, things like that. So at my first company where I've worked, there we started after some introduction to do things on an FPGA, and I was thrown into the cold water, search for an FPGA and just do some research and then doing a little bit of design. And the funny thing is, I've started with a Spartan 3A. Exactly the same. And
of course.
Yeah, and I've started because electrical engineer is working with schematics in whatever tool you want to use. And I'm just drawing, of course, IP blocks. that was okay. So just creating some calculations blocks or where I can configure the DSP or some filter blocks, but also have some gates or flip-flops or things like that, dropping into a schematic and drawing the lines between the ins and outs and so. Oh, it was a very hard work, and it was not very. At the end, it was not a lot of fun to do this. But
your wrist was getting a bit sore from clicking and dragging.
A little bit, yeah. That's
yep.
Not much fun.
No.
On one point, I had the feeling I didn't get further in my design, so I have a lot of timing problems, of course, and a lot of asynchronous signals. And in these days, they're stepping PLC2 in my life after some research. PLC2 is the biggest company in Europe who are doing trainings on FPGA and VHDL and also training on the job. So people of them come for a whole day beside you and helping you. That was the best I've ever had. No?
Yep.
It was genius. And I'm not sure what you're thinking about my design.
Step 1, don't use schematic entry.
Yeah, exactly. And
we've got another rookie here, guys.
So, starting with VHDL was the first step he was doing, and step by step he was converting my ugly schematic design into a quite good VHDL system. So starting by top level and doing some modules and doing some signal stuff, and after that I never have done any design in schematics.
You never went back?
I never went back. From this point, I've working with VHDL, VHDL top level modules, VHDL sub modules, and connecting them over names. And but for complex designs, I think it's not the optimal way. And after some years, and yes, of course, after Vivado is coming with their new approach with the block design, switched over to the block design, and it's quite fun because you have on the one hand the schematic view which every electrical engineer loves. So you have a top level design, and then you click into your top level and go down in the hierarchy to the next one, and so on. And that's why I love this kind of block design, to have an overview over the signal flow from the left to the right, and normally left in the input, right in the output, and between that you have the whole signal flow, and you have your controlling stuff. You have your microcontroller or the sync PS or things like that in one block design. And beneath that you have maybe always, or not always, but most time VHDL blocks or Verilog blocks or things like that. So you can put your functionality in good designed VHDL blocks, but connecting them over block design. I think this is what I'm doing until today. I have not much connection to other softwares. I've worked a little bit with Lattice, mostly with VHDL there. No nice block design software. Maybe they're working on it.
Do they have any so they don't. I didn't think they did. Yep.
I'm not sure. They have, I guess, 3 suites they have created. So
okay.
Lattice Diamond, Lattice, and more suites.
Another gemstone. Yeah.
Another good names.
That's right.
But I've always working with Xilinx or now AMD, and I think Vivado is doing a lot right.
I think so.
Until you want to, maybe you want to copy and paste the graphical block. It's that's not nice. Or if you want to switch from one block to another block, you have to delete the one, and then all the lines are gone. So you have to reconnect them all. If you have a complex design, it's not the best you can do. It's taking not minutes, more hours sometimes. But it's I think it's from the point, if you want to have a good overview over your design, it's much easier if you have it on a block design as you have it on in VHDL modules. So that's
definitely
my view on this point.
Yeah, I was going to say on that point. So I was on a project not too long ago where it was all in VHDL, and it was, thousands of lines, and mostly in sort of a top level where there was a lot of what I'm going to call glue processes, equivalent to glue logic, having random sort of control signals between components, which was just awful. And the hardest thing for me was there was no documentation. And so all I've got to understand this system that I'm working on, because the FPGA engineer wasn't available, so it was just me and no one really understood it, is here I am trying to reverse engineer the FPGA just with the code. And it was almost impossible, right? There was multiple clock domains. It was already failing timing. And then my first step is, okay, what is this thing even doing at a high level? And then the second thing is, where's the data flows? These signals seem to be going everywhere, and you'd sort of have outputs from one going to, these random processes in the top level, which then go to components. It was just a mess. And I feel like getting the overview at a glance is the biggest win of the block design. And it also forces you to work in a more sane way, because if this was sort of converted to a block design, right, you wouldn't really have these floating glue logic around that is very confusing. So I think that's another point that maybe people don't think about when they're, maybe they need to get buy-in at a job of, using the graphical approach. I think a huge benefit of it is understanding of design, and not even understanding, just being able to make modifications safely. Because as you know, with an FPGA design, I could, stuff up a counter on one of those glue logic, and suddenly the whole data flow is halted. Suddenly you turn this product on and it's not doing anything because that counter now doesn't trigger the, ready or valid for the next part of the flow. So I think
just when one signal is missing, one enable line,
literally
one ready, as
right.
you just said, it's when this is missing, nothing is running and nothing is working. So it's or if you have some reset lines not correct connected, that's always a problem.
Exactly. And I think the other thing for listeners and anyone, thinking of using this should remain aware of is that you're not losing control in the act of doing this. And I think this is a big, some people might, put alarm bells up thinking, am I, not going to be able to modify the design as much? Am I relinquishing control? It's not the case at all. You can go in and change the VHDL or Verilog for all your blocks and then regenerate it, basically. So I think you get sort of all the benefits in one. And for those people that, prefer to just look at the RTL, you can. So I think it appeals to all the different types of people that like to work in their way, but at the same time, you don't lose the observability, which, I tell people that I personally, and you probably will agree with this, David, if you've done some software work as well, but if I was to compare understanding an FPGA design to a software design, I'd say it's orders of magnitude more complex for me to reverse engineer what's going on and be sure I know what's going on. So any tool that allows me to get a better insight, I'm going to take it.
Yeah. On the other hand, if you are new to a code, it's always depending how it is written, how the variables are called,
exactly,
what the signal names and what the process names and so on. So the style of the developer is inside the VHDL or inside the Verilog code or in the mind.
Correct.
Yeah,
it's encoded.
not documented really. So it's always a problem on this side. But if you have this graphical approach, you can do a little bit when you are maybe giving the input and output bad names like input 1, input 2, output 3, and so on. But if they have speakable names like audio input or video test signal or something like that, so you can imagine what the signal will do. And maybe you have also some hierarchical blocks inside your top level design. So like pipeline, video pipeline or audio pipeline or controlling stuff or I don't know, debugging stuff. So those are my blocks, and I can open these blocks and close these blocks and shift them away. And you can understand from the input to the output, what is the system doing? It's going to block A, then to block B, and then split it up to block C and D, and so on. So you can follow this stream or follow the data path through the FPGA much more easier if you have a graphical representation. And the funny thing is, sometimes I thought, when I'm moving this block around, it would be safe. No, it will not be safe. You can just doing a rearrangement, whatever you want or wherever you want. And the connection is just written down in the XML file or the block design file. So
exactly.
It is just an XML file. You can maybe, if you want, edit it by your hand. It's not so much
if you're feeling
brave. But sometimes, so if you want to replace one block by another, sometimes it's easier to do this in XML as in the block design.
Correct. Another aspect of that I was just thinking about, David, is injecting ILAs. I find it's much easier to tap into the signals when they're in the block design versus in VHDL files. So, for example, if you've got, an ILA in the top level and you're wanting to probe internal signals within a component, I found that really painful in just the raw VHDL approach, where I'd have to manually go into each of those components, expose those internal signals to, an entity of that module, and then add a new internal signal in the top level, and then add a probe to the ILA instance. I found that really annoying as well. Whereas if I just, had the blocks available in the block designer, I can just put an ILA in graphically and tap the wires like an oscilloscope. I just found that so much more intuitive versus having to, add the ILA in VHDL and kind of plumb signals through. Is that what you found as well? How do you do ILAs with block design stuff?
I was just thinking about it because
it's an interesting topic.
I'm split a little bit in two ways. On the one hand, you took a block, put it into your design, connecting lines, and you have your ILA in your system. On the other hand, if you think about state machines inside your one VHDL block, and the state machine has its own record of variables because it's working locally inside so the state machine and then putting it on the outside to the signals. That is, from this point of view, much easier for me. If you're putting into your VHDL code the debug attributes onto the signals. So you can, the sightings or ND, there you can, I guess also on letters on other systems, you can put attributes onto your signals, and one is the debug attribute that the system doesn't start to erase the names or optimize it so far that you didn't get the design names or the signal names from the module later in your compiled design. And if you have this attribute, I guess it's what debug or things like that. It's a debug attribute, and then you can start with what is it in the synthesis view? You have the debug wizard.
Yeah.
And then you have the real name, and then you can put your state machine or things like that into this. And you can mix up the ELAs into your block design with the ELA you have created with this instance. At the end, it is in your constraint file. It's part of the constraint file.
Yeah, that's right. Yep.
So it's divided into two ways, but to tap a fast signal, it is easier to do this in the graphical system. If you want to go deeper, sometimes it's easier to do this with a kind of wizard or inside your constraint
RTL.
file.
Yeah, constraint file. Exactly. One other thing I was just thinking about as well, going back to the visual entry itself, is how do you use your TCL in this workflow? Do you sort of, like, let's say you've just got a sample project, right? Do you sort of have a TCL file that that basically adds all your source files, add your constraints, and then how do you add the block design? Do you sort of have an initial block design that you then export and use in your TCL? Like, how does your TCL fit into all this? I think this is another interesting point. From your Git point of view, like, what do you check in? This is a big topic, which I've been trying to work out the best solution for many years.
So the best solution for me was to check in my project, not the whole project, but the source files and what is needed. It is possible to create an TCL file for your block design. So the block design is regenerated while the project is regenerated over these. Yeah, with this
that's what I'm doing.
TCL file. That's working quite good. If everything is inside is good defined. I'm not starting too often a new project. I'm just rework existing projects. That's the most of my time I'm working in, and for this I didn't have to regenerate too much. So if it's a new project, a new system, a new device, whatever, I often started at the point 0. So I'm creating a new project file with the correct names and so on, and starting with a blank block design, and then putting all my blocks inside. So.
How do you generate your blocks as well? Sorry, do you sort of have VHDL files that you export the IP and then you import it? What's sort of your entire workflow? Let's say you're doing a new project and there's actually some new modules you need to make that you want to add as blocks. What's your workflow for that?
It's quite an interesting question, because there are two ways on my side. On the one hand, you can have external created IPs. You import them and then you drop it into the design with all the pain. If you want to change anything in this IP block, you have to open it in another Vivado, and then you can do the change and do a repack and then to update and so on.
That's what I've done.
And since, I'm not sure, it's 2018, 2020, was it possible to drop directly an RTL file as block into your block design?
Yes, in VHDL still. I recently thought you could do it for System Verilog. You can't. It's still just VHDL only. Yeah,
it is possible. So I have a project where I've put it in System Verilog block into my block design.
Did it work?
It works because I was on the same problem. I have a very good IP core from an external company for DisplayPort, and I want to use their System Verilog. And then I couldn't put it directly into my block design.
That's what I found.
Yeah, Vivado says no. You cannot.
Yeah.
I say, I want to. No, you cannot. I want to. No, you cannot. So it goes some minutes. And after that, the easiest way was I've created an VHDL wrapper for the system Verilog file.
Okay.
Put this, but the interesting thing is first put the the wrapper as a nearly empty module into my block design. Because if I put everything into the VHDL file and including the instantiation of this system Verilog, it says no. Mm-hmm. But if you put it into...
It's a bit fussy, yep.
Yeah, but if you didn't have a nearly empty block and put it into your block design, it works. And after that, it is into your block design. Then you can put all the system Verilog instantiation logic into your VHDL file. And that works. And also the port updates works. And it's a little bit pain, but you can do it. Yeah.
Okay. No, good to know. Because not too long ago, I was hoping to do a sort of system Verilog type project, and I was hoping I could just directly instantiate the modules in, and I try that, and then I see nothing appear in my block design. There wasn't really errors or anything, but it just was not working. So then I mucked around a little bit more, but I gave up. Just went back to VHDL.
I had no other chance because I want to use this exactly that IP in my design.
Yeah.
And I want to use block design and not system Verilog and not Verilog.
Yeah, yeah, fair enough. Cool.
So, but it works. So Verilog is easy. Verilog blocks you can put as an RTL block. It's easy. But system Verilog, it goes with an VHDL wrapper, empty wrapper, and then afterwards putting all the signal into this block. It's okay. Yeah.
Yeah. Right. Cool.
So we were on the discussion about how to put IP blocks. So, the external IP blocks is all on my side, I didn't like it, the IP editor. So if you have IP blocks you are using in many projects, okay, that's fine. You can do so. But if you just you have to modify the IP, if you use it in another project, why you should use a central IP repository. So all the projects I've worked in were so small, I would say, or the companies are quite small, so they didn't use the IP cores, the internal IP cores, in the same cores with the same code in different projects. Every project has some modification on this core. The idea in the cores is the same, but not this core on this as a
internals.
Yeah. So it's much more easier if you take it and put it as an RTL block. So you just click on it, push F7, and you can edit the source code directly. And after that, you do your updates and the new synthesis and so on. So on my side, external IPs are nice, but for me, it doesn't. For my project, it doesn't work.
Yeah, especially if you have to do a lot of mods. Like I was, working on another project where we were relying quite heavily on external IP, and the amount of times where I would have to go into the IP core, regenerate it, and then run through the whole workflow. It took a lot of time. It was quite painful. So I'm very familiar with that workflow. Yeah, literally, because we found, there were bugs in their IP core. So we were trying to integrate it into our design, and then there are assumptions they had that we didn't have. So we could talk a lot about nice ways to document IP cores as well. Maybe that can be another topic, David. We just talk about documentation, sane documentation.
That's always
save that for another episode. Yeah, cool. But I think that's I was just trying to think other experiences or topics with block design. I think that's kind of it for me. I use the VHDL still for the logic itself, but the block design I primarily use to communicate what it's doing, and just for I guess maintenance and the like. I prefer to use that, and then just use the VHDL when I need to zoom in on the detail. That's the way I'd sort of put it. So
exactly. So we are on the same working the same way. Yeah.
Yeah, exactly.
So looking into the future, well, a lot of people are talking about large language models, and that's the new stuff and the new things, and everything will get better with it. Not in detail.
Yeah, we'll see. No.
So
Please
yes,
no.
what is working good is a large language model create me a wrapper for this file. So and then, that's working quite okay. I'm having a very log file, and I want to have a wrapper in VHDL for whatever, just to include it, and that is working quite nice. Creating some routines. The funny thing the last time with large language models and creating VHDL was I've given it the command and what I want that the code will do, should do, and it's writing all the stuff above and all the comments and the introduction. Everything is nice. And then where it's getting interesting, there was a comment, put your code here. That was, the rest I could do by copy and paste from another project. No help. So, but a colleague of mine, he is doing a lot of large language models also in VHDL, because he's creating some test benches, and sometimes it's
what's
helpful.
he using for that? Is that VUnit, or what does he use for test benches? How does that look?
Yeah, I guess it's VUnit with test benches running in XSIM, because we are on the AMD world. It is also a little pain to create
XSIM, yeah. Yep.
XSIM with some automatic tests, but we have a workflow. We can doing a check-in into our Git, internal Git in the company, and then automatically all the tests are running through and give you feedback if something is failing. So it's quite nice with a Python at the back
using
end.
assertions and things like this, like self-checking test benches.
Yes, exactly.
Yeah.
So
how does Python fit into it? Sorry. You mentioned Python there. How does Python fit into that equation?
Python is using as a control around all the simulation stuff. So there's a running script written in Python because it's the heart of VUnit to control everything. So that's why Python is going here into this things. And Python is much easier for a large language model than VHDL or I guess Verilog.
And with the large language modules or LLM your colleagues using, are they using Claude Code or ChatGPT or OpenAI's models? What were they using for it out of interest? Do you know?
It's a good question. I think it's Claude and it's Mistral. It's from a French company. If you know, it's
no, I haven't heard of them. Okay, interesting.
It's a European large language model. We are using this quite a lot in the company because it's a European one.
So is that in France somewhere or Germany? Where's the infrastructure to support that LLM? Where's that set up?
As I understand it correctly, it's in France. So it's
it is in France. Yeah,
so
I'll have to look.
It's a Europe system, But also for some month, I'm using a local language model, a local large language model, on a quite good machine with a good graphics card, and you need it. So it's I don't know. It's 8 gigabyte video RAM, and the computer has 64 gigabyte RAM, and it's an i9 14th generation. So number cruncher, and there I can run this locally, so nothing of my source code is going out of this network.
Onto the cloud. Yeah, it's going to the CIA. Yep.
Sometimes it is quite interesting to use local LLMs.
I've never tried. I'd be curious to try a local, but I've used Claude for sometimes some quick and dirty module generation, like just a simple component. And I find it gets most of the way there. I then just have to do some, tuning at the end and correcting. But I find Claude Code's quite good for, basic module generation. But But yeah, the test bench side is something I want to play around with more. So it's interesting to know that it works quite, because I would think it would be a perfect candidate for test benches, because a lot of the time it's very formulaic, very structural, very mechanical. It's often not a fun process, especially in VHDL. Right. So that's good. It's good to know.
Yeah. But for the real work in block design, I'm not sure where a machine learning system can help.
Yeah, I agree. For me, I can just see it working in the module entry stage, but that's about it. So, coming up with the VHDL for a module that you then, right click and add to the block design. I can see it working for that initial stage, but any of the graphical, and I can't see how it would understand the XML as well. So yeah, that's an interesting topic. I can't see how it would help with the block design view at this point anyway.
But maybe over the XML file, that could be possible, that if you have an XML file and says, okay, I want to change this block to that block, and you give the block description, maybe a working XML file is coming out, or maybe something different.
Could be something to experiment with. Yeah, no, it's an interesting one. Just talking about it there, the XML is the source truth. So maybe it's possible. It's like with things like KiCad or KiCad, however you want to say it. A lot of that sort of, XML or kind of node pair based. And I'm sure you could probably do some interesting AI things with that as well. But, yeah.
On the other hand, I guess AMD is also working with machine learning, because this is why it's called Vivado ML. Machine learning in the area of fitting your design into the FPGA. So all the place and route stuff. If I understand it correctly, I'm not quite sure, but if I understand it correctly, in this stage, the software is using some kind of machine learning to optimize your implementation. Okay. But I'm not quite sure. I have just to learn something about that.
No, I'd be interested to learn more about that as well, because it's sort of a black box, the way that synthesis engine and that works at the lower levels. Yeah, cool.
It's quite easy, but not for complex design. That's if your design is 95% full, also it took hours to get your design,
or days,
or never working sometimes. So
that's right. Yield of 0%.
Okay, so if we've talked about design approaches with schematics on my side, and then VHDL, block design, and all the pros and cons, I guess. And yes, as Outlook, I'm not sure of changing anything too much in the next years. So we're working with VHDL, or some people are also working with Verilog. And we're text-based on many things. TCL scripts, for example, if you have an Git flow where you can check in your source and all the bit file generation is getting created automatically, there will not be any block design. So if you have a complete source code driven workflow, then block design will not work so quite well, I would guess. But a lot of engineers will work with block designs, so that is my guess.
That's another point I was going to say, David, is you really have to make that decision up front. Transforming any project from VHDL only back to block design is going to be almost impossible. You'll probably make mistakes along the way in the connections, or just the way you may have to re-architect the design to make it work. I think it's unfortunately high risk and difficult to transform an existing project to block design. I don't know if you've got any experience on that, but I wondered about moving to block design for one of those projects I mentioned, and just the cost benefit wasn't there, or the time or the budget. So I had to stick with the VHDL approach. But I think for new projects, you really have to make that decision up front to use the block design approach. What's your thoughts on that? Have you ever tried to convert a project to block design?
Never.
Yeah, but, exactly, right.
When I'm thinking about this, the top level VHDL file is normally only connecting blocks together. So it should be this way.
I guess so. I guess the point is if you it depends how your signals are structured, right? If you've got a lot of these floating processes, that's the problem.
That's the problem, yeah. So you have to export this to an extra VHDL module. So if you have a VHDL file what only will connect all the blocks, maybe in, I don't know, in some month or half a year, language model can convert this VHDL file to an block design XML file. Maybe. So as an import path. But I'm not sure if this works really, or if you just want to sit 2 weeks and draw it on your own. Maybe it is easier. So I don't know. I've never seen this import strategy or export strategy to VHDL. So no.
Right. I was just one last question I was going to ask you there. Did you mention you're using Intel FPGAs as well, like Altera? Do they have a similar flow, like block design flow? I haven't used Altera FPGAs in many years, so I was wondering if you've been working with them lately, do they have an equivalent workflow?
I don't know. I've never worked with Altera.
You don't know either?
Or Intel or Altera, the Intel company.
Yeah, okay.
So they're just changing names.
Yeah,
so,
exactly.
No, I've never worked with Altera. I've started a little bit as I was researching about FPGA platforms some years ago, but I'm more or less fixed on the flow of AMD. Yeah,
you're locked in.
I looked a little bit into the
Phoenix
design part. No, not Phoenix. It is a Cologne chip, so the German company. It's a German FPGA company, or the only European FPGA company.
European. Yeah.
So it's in Cologne here in Germany, and their workflow is complete source code driven. So you have a make file.
That's what I thought. Yep.
At the end, you have a make file, which is all calling all the tools, and this is unbelievable fast. So they have shown it on the last FPGA conference, and they had a board and they had their standard laptop, and he just started the making script, and after, I don't know, 10 seconds, the whole thing is compiled and transferred to the FPGA board. And it was a design with some gigabit controlling or gigabit connection.
So it wasn't basic.
It wasn't so basic, no. Was a little bit more. So it was impressive. It is a complete open source tool chain.
Interesting.
No?
The whole thing, so synthesis, they use open source synthesis, open source place and route.
Yes.
They maintain themselves, or they basically consume them into their tool chain?
They just... I guess they help the open source tools to do all the place and route for their FPGA. They have opened up their design to them. What is AMD not doing? This is closed. So it's only a guess how the place and route is working until the bit file. But for a Cologne chip, they have just opened it and working with open source tools.
I'll have to have a look. Yeah, that's really cool. They don't have any SoC type FPGAs at the moment, do they? It's purely logic, right? Like they don't have ARM cores available.
Only logic.
Yeah.
They can have, so they can saw only one chip out of the wafer, or 2 or 4 or 9. So it's, they can scale up the FPGA size. That's interesting because they are all the little FPGAs are connected inside the silicon to the other FPGA. So the routing is possible between 2 FPGA chips. It's quite a good idea because the silicon design is quite expensive. So all the masks and all the processing and so on. And when you have tested the dies, you can say, okay, I just cut out 4x4 dies as one chip and put it in one in one package. So this is possible. It's a nice idea. I guess they have a patent on this. But do
they have any Yeah, go ahead. Sorry.
Yeah, I had no time to test their FPGA platform, to be honest. But in the future, I guess I will do more on this just for testing, just for getting into this FPGA platform more and more.
Yeah, because I was going to say, I play around with Phoenix quite a bit, and I find they're quite good because they've got a lot of SoCs support now. You know, they've got sort of hard RISC-V cores and this sort of thing. And so I guess one of the other areas I'd like to look into more is the soft core implementation of like a RISC-V. So I'm wondering if with GateMate, you could potentially, within the PL, instantiate a RISC-V core and, you know, have a workflow around that. Maybe that's an option. I guess it depends how much logic they have and how efficiently you can build it up. But it's an interesting one.
I guess for normal controlling applications, it's the size and the speed should be okay for
correct.
For standard things where you also use microblaze in an RTX FPGA. They can, I guess, it can run 50 megahertz, 100 megahertz. It's fast enough for controlling stuff, I guess.
Yeah, exactly. Cool.
Well, just not going too much from our topic to other topics,
that's good.
but it's all the artificial intelligence.
It's all
stuff
connected.
are interesting, and we have to do some research also as FPGA developer on this side. So also on the embedded world, where I was, I guess it was 2 weeks ago. Yeah.
Yep. Probably 2 weeks ago. Yep.
Around 2 weeks ago. Every booth was about AI. Nearly every booth. It was
AI snake oil. Yep.
Exactly. That's the right word for this.
Right terminology.
The snake oil AI. Mm-hmm. On the one hand, you have displays. On the other hand, there was AI, and only a few companies have shown other things. Well. I guess I have
that had AI.
I planned to do a episode about this, but that's
All right.
First, this was much important to talk to you.
Yeah, no, absolutely. No, it's good. Cool, interesting. Always learn things.
Okay, I guess we have it for the moment for today.
Yep. Yeah, all good.
One interesting thing for all is we are on Spotify and we have more than 100 subscribers who are listening to this podcast. It's amazing.
Yeah, that's very good. We've made it, starting to make it.
Yeah, 150, I guess. Yeah.
That's it. We can set goals. Yeah, we've still got some way to go.
Yeah, that's nice, and I hope it will not take again. What was it, 6 months?
Yeah,
but now
right.
the time of illness is gone on my side.
It's past. Yeah, it's coming on my side.
It's coming on your side. The winter is coming.
Still a couple of months.
The winter is coming on your side. Yeah.
That's right. Yeah. The childcare sickness is coming on my side. Oh, please no. See how we go.
Always sick kids, yeah. Okay.
Yeah, exactly. Yeah, they're good at that.
They're good at that, yeah. Okay, then we will talk again in the next episode about, I don't know, we will find a good topic, I guess.
Yeah, exactly. I'm sure we'll come up with something.
So then have a nice day on your side. Have a nice start into the week. And then we will listen again in, some days, weeks, or something like that.
And you'll upload it to tomorrow, your time, something like this, within the next few days?
Yeah, I think so, yeah.
Yeah, no worries. All right, cool. Thanks, David. Great talking to you again. And let's try and have a more regular cadence next time. Let's see how we go. All right, okay. Enjoy your evening.
Goodbye.
See ya. Bye.
If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye here next time, your David Kirchner.